Okay, so we're going to look at exponent rules in general. And so I'm going to write our exponent rules over for us again. We have some base to the 0 power is 1. Some base to the first power is that base. If I multiply two things with exponents and their bases are the same, I can add their exponents. If I divide two things with exponents, I can subtract their exponents. And if I take something with an exponent to a power, they multiply. If I have different things, all taken to a power, then that power multiplies to each thing. And these are general exponent rules, or the law of exponents. I think I've seen this called the law of exponents. All right, but these are all the properties that we get from exponents. So let's look at a couple of examples here. If we look at negative 5, whoops, I have my negative in the wrong place. Let me correct this really quick. 5 to the negative 2, all squared. So I'm going to use this power to power rule. So this is the same as 5 to the negative 2 times 2, which is 5 to the negative 4, or 1 over 5 to the 4th. Because negatives pull powers down, I guess I could add up to my rules here. B to the negative 1 is 1 over b. All right, we can negative exponents pull things down. All right, let's try one more here. And let's look at one of our more complicated examples. Let me scroll down here. So I'm going to have a fraction. And I'm going to have negative u cubed v cubed divided by 3vu to the 7th. So negative u cubed v cubed divided by 3v u to the 7th, and the whole quantity is squared. All right, I'm going to think of this in parts. The negative out front is a negative 1. Okay. And I'm going to use that power rule where I'm going to bring everything through. So I'm going to have negative 1 squared. I'm going to have u cubed squared. I'm going to have v cubed squared all over 3 squared v squared u to the 7th squared. So notice this power gets applied to each factor in there, no matter which side of the division bar it's on. Well, a negative squared is positive, so my negative sign goes away. U cubed squared, my rule says I multiply those exponents, so that's u to the 6th, v to the 6th, over 3 squared is 9, v squared, and u to the 7th would be u to the 14th. Now here, I have u's upstairs and downstairs, and v's upstairs and downstairs. So I look for the biggest power. So I know my 9 is going to hang out down here. Well, the bigger power of v is upstairs. So 6 minus 2 leaves me with v to the 4th upstairs. And my bigger power of u is downstairs. So 14 minus 6 is u to the 8 downstairs. And we've simplified that. Another way you can do it, you can bring your u's and v's together before we start. So I'm going to, in blue, just take this in a different route. I want to look at this here, so let me rewrite it here in blue. and take it to the second power. And I'm going to start inside the parentheses. So I have a big power of u downstairs and a smaller power of u upstairs. So I'll do my subtraction. 7, and I'll leave my -3 out, or the negative and the 3 out here. So 7 minus 3 is u to the 4th, and 3 minus 1 is v squared. Now I'm going to take my power of 2, so I'm going to have my -1 squared, v squared squared, over 3 squared, and u to the 4th squared. Negative times negative is still positive. That gives me v to the 4th over 9, u to the 8th. Hey, same thing. Same thing. Two different ways to get there. Same.